So my name is Winter, so we're going to go over some other electrical components in addition to the ones we've already learned. So one of the main components we use are capacitors. Capacitors are basically two plates. So we have two metal plates, usually at a very small microscopic level that we can't see. So two plates. And so when we connect this device to a battery, right? We've already discussed how batteries have more negative charge on one end than the other and more positive charge on the other end. So what happens is that because these charges like to even out and space out, because they have this new plate, this new metal to be able to spread out, they all tend to pile up on this plate. So negative on the battery, we get many negative charges. And then on the top side, we get many positive charges. And because the plates aren't actually connected in between each other, these charges can't actually go interact with each other. But because they're so close and there's so much of them, they still exert forces because they want to be with opposite charges. So basically what the capacitor does, it creates a field inside. This field creates a lot of energy and power due to the attraction between these. So capacitors are basically used to store energy, so these charges come onto these plates. Something to note is that when we have, say, a battery connected to these plates, it'll eventually reach an equilibrium. So at some point there won't be any charges moving because the plate will have all the charges spread out evenly and they'll all be happy. So for capacitors, we'll usually be using AC power sources or alternating current. So a battery is an example of a DC power source, which is basically, it has a single voltage and that's all it puts out. Whereas in AC power source, the voltage will vary across time. So it'll turn, say, like on and off and on and off. And so that change causes the capacitor to usually be able to charge and discharge. So if I took this capacitor that's charged and stable in this circuit, it has power. So if I connect it to another circuit, it can give power to that circuit, but it only has a limited supply. So if we connect this, say, to an LED, the LED would light up briefly and then dim out because it used up all the power in there. So that's one of the main things. Capacitors either come polarized or unpolarized. So the unpolarized ones are the kind of round ones on those slides. Those versus the polarized ones. So the polarized ones are directionally, you need to put the long leg as the positive leg and the short leg as the negative end, or else the capacitor will not work. It will usually break. This is just due to the materials used. And yeah, we usually use capacitors with resistors with AC circuits, so charge isn't directly going to components. So inductors are our second major component that store energy. So unlike the capacitor, inductors are basically a coil of wire. The way we symbolize this in circuit diagrams is basically a spiral. And so with inductors, the way that electricity works, because the current, so when current flows through this inductor, it'll spiral through all of the loops. And this effect of the current going through these loops causes a magnetic effect. So the magnetism does not like the fact that the current is just going through so it'll usually oppose the change of current. So capacitors, for the most part, are used for changes in voltages, whereas inductors are more for changes in current. It's not so important for you to know how the mechanics of this works. This is more magnetism related, but for the most part, you just know that these have to relate to changes in current, but they do store energy in some ways, while capacitors do the same thing, but with voltages instead.